AMCASH, Advanced Materials Characterization Simulation.
As a part of the AMCASH demonstration series, this talk is about the high-speed camera that the University of Birmingham owns as part of the AMCASH project. I am Richard Turner. I'm a research fellow at the School of Metallurgy and Materials at the University of Birmingham. Okay, so the high-speed camera that the AMCASH project has got access to is a Photron Fastcam Mini UX100. This is a monochrome high-resolution camera. It allows up to 6,250 frames per second for a full windowed view frame of 1280 by 1024 pixels. We can go up to 200,000 frames per second if we allow for a smaller window of view. The camera has got a 32 gigabyte internal recording memory that allows for 18,000 frames to be saved. The camera has got intelligent trigger mode, so we can capture dynamic action in a way that suits you best. The camera has independently controlled frame rate and shutter speeds. It syncs with PFV software on an external laptop. And you can save to AVI, WMV, MOV, and other kind of video formats. The industrial uses for a high-speed camera can be wide-ranging. Often we use it in conjunction with the drop tower that we have at the university, which allows us to assess the material response to an impact of a known energy. However, our camera and our lighting are perfectly portable, so we can take them to any locations to record in-service impacts and rapid manufacturing processes at various factories, workshops or test centres. The experiments capable of being monitored by the high-speed camera include material fracture or shear, a controlled crack propagation study, a material compression under impact study, a spark or a flame monitoring exercise, fluid flow and fluid properties. Industries using this can be as diverse as metal forming, sports materials, ceramics engineering, safety testing, or food and drink. Okay, so I'd like to give a demonstration now of the camera's capability. So on the right hand side of the screen we can see a recording using our high-speed camera of the shattering of a ceramic ornamental pot as a drop hammer falls on it. So this video was recorded at 4,000 frames per second, and as with any high-speed recording, getting enough light into the frame is crucial. As the frame rate increases to higher and higher frames per second, so the exposure time per frame is reducing. So we must illuminate our sample and our object sufficiently such that in that microsecond of exposure time, the camera has got enough light entering the lens to allow full visibility of our specimen during processing. And so for another video from our high-speed camera, this time looking at liquid flow behaviour. So it shows the pouring of water into a vessel, and because the camera needs a line of sight, we've used a clear glass. And we can analyse the video to understand the rapidly changing fluid behaviour under specific process conditions. So we can look at things like the viscosity. We can use the results to measure what the viscosity of the fluid is, and we can imagine doing an experiment at two different temperatures and seeing how the viscosity changes with temperature. We can try and use the video to analyse to see what the surface tension of the fluid is. We can look at cavitation of flow, so when do we lose that steady state pouring of the water into the glass. And within the water that's settling in the glass, we can look at air bubble formation. So this kind of use of the camera is suitable for maybe research and development within the food and drink industry. So there is a multitude of other potential uses of the high-speed camera across many different industrial sectors. One use I could record at home was the sparking and ignition of a standard flint lighter, which we can see in the video playing on screen. Other uses would include perhaps vehicular crash and damage monitoring, ballistic impacts, and many others. If you have any interest in using the high-speed camera as part of the AMCASH project, or if you've got any questions about the support that AMCASH can offer to regional SMEs in the West Midlands, then you can either contact myself or you can contact the AMCASH project directly, and the contact details are on screen. Thank you very much.